Okay, so this is a floating point number representation problem. So we have already discussed what is floating point number and how it is represented. So in this example, this question was asked in 2005 GATE examination, and the question here is, you can see that the consider the floating point format. Now first see the format. Now the format is actually, you can see the format. So in the case of the format, you can see that the I have already said in the floating point number representation that in the floating point number representation there is sign bit, sum of the bit reserved for sign bit, sum of the bit reserved for exponent bit, and sum of the bit is reserved for mantissa bit. Okay, so here you can see the sign bit is 1, 14 to 15, so 1 bit is reserved for sign bit, and to 14 to 8, that means 7 bit is reserved for exponent, and mantissa part 8 bit. 0 to 7, that means 8 bit. These are the reserved bit for the sign, exponent and the mantissa. So this is clear. Now it has been said that mantissa is a pure fraction in sign magnitude form. Okay, so mantissa is, obviously he has said that the mantissa is a fraction in the sign magnitude form. This is okay. So okay, so 1 minute. Okay, so normalized representation of the above format is specified as follows. The mantissa has an implicit 1 preceding the binary radix point, and assume that only zeros are padded in while shifting a field. That means this question is based on implicit representation. Now in the case of the implicit representation, I have already said that in the case of the implicit representation, number is represented by minus 1 to the power s 1.m, that is the mantissa representation, and that means this is radix point, and before the radix point there is only 1. So that has been written down here that it is has the mantissa has an implicit 1 preceding the binary radix point. Okay, so it is represented by 1.m mantissa like this format, and also assume that only zeros are padded in while shifting a field. We will see that the normalized representation of the above number 0.239 into 2 to the power 13. So the number is 0.239 into 2 to the power 13. So that is your exponent field and that is your mantissa part. Now it is represented in the decimal format, so you have to convert this number first into a binary format. So here you can see that the mantissa is 8 bit, reserve 8 bit for the mantissa part. So while converting this number into a binary, we will only consider up to 8 bit, and after that we will not consider any number. Okay, so while converting it to binary, you know the rule 0.239 into 2, so that is 0.478. so 0 is there. Next 0.478 into 2, and this is 0.956, so again 0. Next 0.956 into 2, so 1.912, so this is 1. Next 1.912 into 2, and sorry, not 1.912, it is, I have written down a mistake, 0.912 into 2, and that is your 1.824, that is 1. Next 0.824 into 2, that is your 1.648, so this is 1. Next 0.648 into 2, 0.648 into 2, okay, 0.648 into 2, so that is your 1.296, so that is again 1. Next 0.296 into 2, that comes out to be 0.512, that is 0. Next 0.512 into 2, this is the final step, 1.0 2 4, this is 1. So this is 1 2 1 2 3 4 5 and 6 7 8. So we will consider this up to this. So the final number for this binary decimal number, fractional decimal number, while converting this fractional decimal number to the binary equivalent, this is the steps. Okay, and we will consider up to 8. At the mantissa is 8. So the number is 0 0 1 1. Okay, 0 0 1 1, next 1 1 0 1 1 1 0 1. Okay, so 0.239 10, while it is converting to binary, it becomes 0.00 11 11 01. We will consider up to 8 bit. That is the case. Why we consider 8 bit? Because mantissa is 8 bit. So we will stop after 8 iteration. So the number can be represented. So previously it is 2 to the power 13. So number can be represented like this, 2 to the power 13. That is the decimal, and that is the binary equivalent. Okay, binary equivalent of that number. So up to this, I hope it is clear to you. Okay, there is no complication up to this. And next we need to align the mantissa towards the left to get normalized number. In the case of the normalization number, and the question, it is mentioned that during the alignment process, zeros will be padded while shifting. Zeros will be padded at the right hand side, and as a result of mantissa alignment to left. So, and also it has been said that, I am just reading out the questions. So the normalized representation of the above format is specified as follows. The mantissa has an implicit 1 preceding the binary radix point, and assume that only zeros are padded while shifting a field. So the meaning of that is that this number have to be represented 1.m format. So 1 point, so you have to shift this 1 to 3. Okay, so 1.11, this 2 1, this 3 1, actually 3 1 and 0 1, and you have to, that means 1 2 3 4 5. At the mantissa is 8. It has been said in the question, you can add zeros are padded while shifting a field. So I have to pad 3 zeros because mantissa is 8 bit. So it has been 2 to the power 10 because it has been shifted 3 point. So that's why it has been 2 to the power 10. So that is the representation asked in the questions. Okay, so your exponent will be, actual exponent will be, in this case your actual exponent is equal to 10. You can see that actual exponent in this representation, after representing the number, that means normalize the number in this format, and your exponent will become 10. But in the question again it has been written that XS64 exponent. So you have to represent the number in XS64. That means exponent should be represented XS64 format. So your actual exponent is 10, while representing the exponent in XS64, that means you have to add 64 with the exponent. So your exponent is become 74. Okay, and the binary equivalent of 74 is 74. This is the exponent. While converting the binary equivalent of this number, it will 100. You just verify this 1010. So this is the 74 binary equivalent, and obviously sign bit is equal to 0. Number is positive, so sign bit is equal to 0, being a, as the number is a positive number. Okay, so that is all about the question. again repeating, that means in the floating point representation, sign bit, exponent bit, mantissa bit, and in the question it has been said that sign bit is 1, exponent bit is 7, mantissa bit is 8, and also you have to represent the number in the implicit format in the floating point. Okay, and you can see that I am just converting 0.239 into a equivalent binary. This is the process, and you will get the corresponding binary equivalent. This is the binary equivalent. Exponent will be 2 to the power 13, but in the question it has been asked to convert this into 1.m representation, so that's why it is 1 point something, and you have to add as many as zeros which are while shifting, so you have to add zeros here, and the exponent become 10. But in the question again it has been said that exponent in x64 format, that's why we have added 64 with that, it will become 74. So binary equivalent of 74 is this. So your final, also sign bit is 0 as the number is positive. So your final representation, will be sign bit is 0, and after that exponent 7 bit, so 100 74 1010. This is the 74 representation. This is your exponent, this is your sign, and next is your mantissa 8 bit. Mantissa 8 bit you can see here from the mantissa 11101 000 11101 000. So this is the total 64 bit 16 bit format. And next is the, you have to convert this, and the question, all of the options are given in hexadecimal. Option D is not shown here. Option D is, while zooming it, it will be goes out. Option D actually is 4A E8. That is the option D. Okay, so I am just converting this into a corresponding hexadecimal. So 44 will be required. Okay, 4444. Okay, so 1 2 3 4. This will be 1. And next 1 2 3 4, again 1 2 3 4 and 1 2 3 4. So you can easily say that 100 means it is hexadecimal equivalent is 4, and 1010 it is 10. Actually 10 means it is a hexadecimal A, and next 1110 it is actually E, that means it is 14, and this is 8. Okay, so your final representation is 4AE8. So your final representation is 4AE8 in the hexadecimal format, because it has been asked in the question in hexadecimal. All of the options are given in hexadecimal format, so that's why you have to, option D is correct, 4AE8. Okay, so that's why I am just converting the number into its corresponding hexadecimal format. I hope this is an interesting problem. Thank you.